Welcome to the lecture The Overall Picture. In this lecture, I'm going to show you the solution at a glance that you are going to design, implement, and test within this course. Let's start with the first component, namely the source system. In our solution, the source system is based on Confluent and consists of the following two subcomponents. The first one is a Kafka topic, which contains the serialized message data that will be consumed. The data format used for the serialization process is Avro, which brings me to the second subcomponent of the source system, namely the schema registry. The schema registry is used for administering the Avro schema, which is required for serializing the message data before publishing it to the Kafka topic and deserializing the message data after consuming it from the Kafka topic and before populating the data to the target system. That in turn brings me to the next component of the overall solution, namely the target system. The target system is intended to be populated with the data published to the Kafka topic. In our solution, the target system represents a relational database system and is based on MySQL. Therefore, you will see, for instance, which factors to consider when populating message data to one or more database tables in a performant way. Now I have mentioned one of the three key aspects this course covers, namely performance. This is the moment when the final solution component based on MuleSoft comes into play. Let's have a look at the subcomponents that make up the MuleSoft component. The first one is a process API, which serves, as you will see, for numerous purposes. The first purpose consists in the interaction with the Kafka topic, firstly the publication of the messages and secondly the consumption. As you can see, the message data will be consumed in batches. This is one fundamental aspect when it is about consuming message data in a performant way, as you will see later. The next purpose the process API serves for is the usage of the schema registry. As already mentioned, the Avro schema, which is required for serializing or deserializing the message data, is administered by the schema registry. In order to avoid that a complete Avro schema has to be embedded into each message when published to the Kafka topic, the schema registry is used to replace the schema in the message by a numeric schema ID, which identifies the schema and vice versa. This task is also executed by the process API. The next purpose also brings the next subcomponent into play, namely the system API. This API directly interacts with the target system in order to populate it with the message data, and for this to be done, the message data is passed by the process API to the system API, which in turn performs bulk insert requests to the database. As you can see now, there is a strong connection between the way the data is consumed from the topic and the way it is populated to the target system. Namely, in order to perform bulk insert requests, the message data has to be available in a bundled form, which is achieved by consuming the data in batches. And this, in turn, explains why batch consumption is a fundamental aspect when it is about consuming message data in a performant way, as bulk insert requests are significantly more efficient than single insert requests. The next purpose of the process API is also the second of the three key aspects this course covers, namely error handling. When consuming message data from a Kafka topic, you have to take into account several error scenarios that will require you to classify the error and take appropriate action, such as message filtering when dealing with message batch containing one or more messages that cannot be consumed as expected. All error handling specific to message data consumption will be implemented in the Process API. The final subcomponent is also the third of the three key aspects this course covers, namely reusability. As you will see, the Process API contains several recurrent implementation components. Without reusability, all these components would have to be repetitively implemented, resulting in significantly more implementation effort and error proneness. In order to avoid this, you will make use of a library in order to extract recurrent implementation components into reusable elements. This is a particularly exciting topic as the interaction between the Process API and the library can be done in a bidirectional way. As you will see, this will enable you to reduce your Process API implementation to exactly those parts which are specific to the respective solution. I hope this has been a good appetizer for you, and I look forward to seeing you in the next lecture.